Hello, in this video we're having a look at the radial component of spherical coordinates. So first we have to set up our spherical coordinates by some use of vector math and math nodes. And once we got our spherical coordinates, which means the radial component and two angles for our spherical longitude and latitude coordinates, then we can start to map some textures into space and manipulate them along these spherical axes. So for volumetric effects, this is a very crucial setup, and we're going to use this setup for combustions as well as magical effects of emitting clouds from a source. So let's jump right in. To get cylindrical coordinates, we first start off with a texture coordinate node and add a separate XYZ node and add a vector math node set to multiply. We connect the object coordinates to the separate XYZ node. Connect the object coordinates to the vector math node and set the factors to 1, 1, 0. Duplicate the vector math node and set it to length. Connect it so that we get the horizontal radial distance of a point in space to the center. Set the math node to arctan 2, the axis tangent, and connect the x and y values of the separate node. This will compute the angle of a point around the center. And finally, directly connect the set output to the set input, since the height along set stays the same. If we use these combined coordinates for our grid, we see the cylindrical axis. We can add our previous twist transformation applied onto our cylindrical coordinates to get even more complex coordinates. I want to offset the radial axis before we twist around it, so let's add a mapping node for this. I set the x location value of the mapping node to a negative value. Remember that the first component of our cylindrical coordinates is the radial axis. A negative value offsets the radial coordinate 0 away from the center axis of our mesh, outwards to the radius we set in this negative offset value. If you now twist around the y-axis, we can see something which is known as a dipole field. It looks similar to the magnetic field of Earth. Since our green y-axis now is not infinitely long, but rather finite circles, we need to ensure that within such circle we have a full number of twists. Otherwise we see a break in the green axis. I correct the value from 6.8 to 7 full twists. We can add a second mapping node after the twists so that we can offset the y location and rotation in a detailed manner. Okay, but now spherical coordinates. So let's look at the untwisted cylindrical coordinates again and modify the setup. Enter the node group by selecting it and hit the Tab key on the keyboard. Duplicate the combine XYZ node and the math node. We can use the angle phi we already have as second coordinate for spherical coordinates. It's the longitude. As radial distance, we can duplicate the r vector math node and connect the vector input of the node group. The cylindrical radial component is flat and the spherical also accounts for the set component. We connect the incoming set component to the math node and set it to compute the arc cosine for the latitude angle theta. Connect the combine XYZ to the output and we're done. Now we can connect the spherical coordinates to the grid and we see the three spherical axes. Use a mapping node output to move them. I'll let you play around with this type of coordinates on your own. So you see we can do all sorts of effects if we turn our XYZ axis into spherical coordinates and manipulate these axes instead. In the next video, we would like to bend and taper our coordinates, which would be a little bit easier, of course, because we're just manipulating along one axis. And in the previous video, we made a lot of rotations. In this one, we took a look at the radial component. So we can think of the next video that we will have scaling variants of space to taper everything. Hit the like button, subscribe to this channel to get notified if new videos are uploaded, and have a look at my products on Blender Market. As always, happy blending. See you in the next video. Bye.